what equation? Because that's the only thing that I don't have on here. What is the formula for the horizontal asymptote? And what is the formula for the vertical asymptote? Ma'am? That would be vertical. Horizontals? Y equals K. Make sure you don't mix those up because then you'll get both questions. I'm not sure. I don't know a way to memorize that. Maybe I'll try to think of something.
Just look at K, Y, and H. According to the equation, at least, where it's placed.
Whatever works for everyone. So the first two examples, I don't know why I gave you so much space, but I did. There's really not any work to show. We are writing the equation for the translation of, now in this case it's y equals 3 over x instead of 1 over x, with the given asymptote. So if you remember, your general form is a divided by x minus h plus k. So all you have to do is identify what your h and k values are from the asymptotes and plug them into the equation. Now in this case, they told us that the a value is 3, so just when you're doing these, you're going to use 3 because of the directions. So the formula for the vertical asymptote is x equals h. Therefore, h has to be 0. If x equals h and x equals 0, h has to be 0. And horizontal is y equals k, so if y is equal to 2, k is equal to 2. If you want to think back to geometry, that's kind of using the transitive property. A is equal to b and b is equal to c, then a is equal to c.
I don't want to remember.
You don't remember that. Okay, sorry. So now you just have to plug in the h and the k. Again, remember, because the directions tell you that a is 3, and you're done. Y equals 3 divided by x. Now you really don't have to put minus 0, but if you want to, you can. The other answer would just be 3 divided by x plus 2. One of those two answers. See if you can try example B on your own. Same direction. Write the equation based on the given asymptotes of the translation of y equals 2 plus 1. Remember, the formula is a divided by x minus h plus k. So when you plug in that h is a negative 2, the two negatives become a positive. The plus k is still just plus the k value, which was 1. So this was your h value, this was your k value. And just be careful that you know the original formula is the minus. All right, on the back we have a word problem. And then you guys are going to do the closure with a partner, graphing and answering all the questions basically from what we did yesterday. So this one says, the lacrosse team is renting a 52-passenger bus for a day trip. Let's underline that. The cost of the bus is $650. 4 passengers will be chaperones. If the students who attend share the cost equally, what function models the cost per student C with respect to the number of students N who attend? So let's write that out just so you guys can see. C equals the cost per student. They defined these variables for us with respect to the number of students, so that's N. Then we also have to define the domain and then use the function to figure out how many students must ride the bus to make the cost per student no more than 20. So it's a 52-passenger bus and 4 people are chaperones, like teachers or coaches. So how many students maximum could go on the trip? 48. 52 total passengers minus 4 chaperones. $48 is the max number of students that could possibly go on this day trip. So that will affect our domain. whenever we get to that part. Let's write the function first. But that would be the possible number of students. Either 0 to 48 students could go on the trip. Who thinks they could write a function to model the cost per student with respect to the number of students that need to attend if we're dividing $650 evenly amongst each student? So,
Will it be will I equals 650 divided by
perfect, almost. Instead of y equals, it'll be c equals.
C equals
Yep.
650.
C equals 650 divided by n.
N.
The cost per student will equal 650 divided by the number of students. Okay? So that's our function. What is the domain of the function? So we said the domain of this function, you don't want to think about, generally, since it's a word problem, it's going to be a restricted domain based on the numbers and the situation. The max number of students is 48, so the domain would be from 0 to 48. So you can either say 0 is less than or equal to x is less than or equal, well, I should use n, huh? 48. Because 0 students could go, 48 students could go. Or you could use interval notation, which would be bracket 0 to 48. Or you could use words and say any numbers between 0 and 48, including 0. Yes.
Could you say that n cannot be equal to -1?
But then you also say it can't be equal to -2, -3, -4. And we also probably should say that they can't have decimals. We can have like a fraction of a person, can't we? So let's use whole numbers.
I mean, if
Remember, integers include negatives. Whole numbers include 0 and above. So these would be whole numbers between 0 and 48. That way we know we can't have a decimal. All right. So we got the domain. How many students must ride the bus to make the cost per student no more than 20? So instead of an equation, the word no more than, we're going to have to use an inequality. So we're going to take this and modify it. How many students is what we're looking for. What inequality would we use for no more than? Greater than, less than, greater than or equal to, less than or equal to. No more than. At the very most, $20. Aiden?
less than.
Less than or equal to. At the most, $20. So less than or equal to 20. Then you have to solve for n. So we'll undo division of n with multiplication of n. Undo multiplication of 20 with division of 20. And we should get a decimal. 32.5 is less than or equal to n. So I'm going to switch that around so the variable's on the left. N has to be greater than or equal to 32.5 students. So we can't have 0.5 students. So what's the closest whole number that is greater than or equal to 32.5? 33. So we would need at least 33 students. That will keep the cost under $20 per person. You could have more, and then the cost would be less than 20. All right, closure, I want you guys to get together with a partner. You can do it alone if you want. I want you to do all parts of the closure. So graph the function, state the asymptotes, x-intercept, y-intercept, domain, and range. And then whenever you're done, you can come up and show it to me. I will check it and then give you your homework to work on for the rest of the class period. You may use your notes from yesterday to assist you if